right, hey guys, we are going to do this next experiment together today. And as we go through here, you are going to be working on your lab report. And this is in Energetic Connections in that packet. And I am on page 39. Okay, page 39. And we're going to be starting right here where it says part 2 to do this lab today. So let's just take a look about what this lab's about before we start collecting any data. So Wyatt's running the camera. He's going to kind of show us kind of what's happening here. So today we're going to be looking at chemical energy, and we're going to see if a burning gumdrop or a candle will make the biggest heat transfer to a vat of water. We're going to use both of those sources, and we're going to heat up some water, and we're going to see which one actually does a better job of doing that. Okay, so just stay over here for right now. So right now, I want you to make a prediction. So Wyatt's going to focus that. That first question there says, there is more energy transferred from the blank than the blank. So do you think there's going to be more energy transferred from the gumdrop or from the candle? Which one do you think is going to heat the water hotter given the same amount of time to burn? So just make a prediction. All right. Now we're going to kind of do this lab, and I will kind of talk you through this, and we'll take some notes, and then I'll post a picture of these data tables when I'm done. So first of all, we need the temperature of water. Now, if you back this up, Wyatt, and kind of do this, I have just some water. Back it up a little bit so they can see it. In a little tin can that I can burn. And I have had our home thermometer here inside of it for a while, and so that we can figure out what temperature this water is. And so this is in degrees Celsius. And what is it, Wyatt?
21.6.
So 21.6 degrees. And that's just what room temperature water came out of the faucet maybe 10 minutes ago. And so Wyatt, move back over here. That is our before temperature. And I'm going to write that down too. So 21.6 degrees Celsius. And then what do you predict is going to happen? What temperature do you think that'll get to by burning this gumdrop with the water? Any idea? What we're going to do is we're going to light the gumdrop on fire. And notice that the gumdrop and the candle are about at the same height. I'm going to kind of move out of the way here a little bit so we can get a little more straight on view. And you can kind of see that they are set at the same height. This little apparatus is going to sit right above it. And I'm going to put the gumdrop kind of right in the center. The water is going to sit on top of that. And as the gumdrop burns, we're going to watch this temperature and see how hot it gets. When the gumdrop is completely black, we'll stop the timer because we want to, however long it takes that, we want this candle to burn the same length of time. It's kind of the constant in our experiment. And we'll see which one raises the temperature the most in this water. So I'm just going to leave my thermometer in there. I've got my match. I'm going to light this gumdrop on fire here. I'm going to get my timer ready.
It's so cool.
See if I can get it to light. I'll have to try again. Let's see, it's burning, but it's not catching fire, is it?
It's gonna melt.
All right, it's on fire now. If you can see it, the gumdrop itself is burning. And I've started the timer. So we're just going to let that gumdrop burn.
It's almost all the way black.
And we'll see what we can do here.
Probably not even touching it.
The temperature is rising. Oh, I got to relight it. It said it may go out, so we want to keep it burning until it's all the way black. Oh, I blew it right out. That wasn't very good. Is it on fire?
Yes. It is.
So we're up to like 22.4, so it only rose about a degree so far. Keeps going out, doesn't it? Yes, I'd like to get this one more side here to burn. It doesn't burn very well, does it?
Mm-mm. It gets caught and then it goes. It's on fire.
Okay.
Doesn't smell
Let's call
nice.
that kind of done. And
45 seconds.
it's pretty black around the outside. Wyatt, do you want to bring it up here and kind of see how burnt? And we got up to 23.3 degrees. You can kind of see the gumdrop. It's pretty burnt and black pretty much all the way around, especially on that one side. Kind of looks like a burnt marshmallow. So we got up to 23.3 degrees. And I'm going to write that down. And I don't know what your prediction was.
I thought it was in 1.
Okay, that's kind of what it shows there. So it went from 21.6 to 23.3, and we'll calculate the difference. We'll subtract those two numbers in a little bit. And it burned for 1 minute, 45 seconds. So once I get the candle lit, we'll let it burn for that same amount of time, and we'll see how much difference we can get there. Okay? So what I'm going to do is let Wyatt go get some fresh water so it's the same temperature.
Hot.
Nope, not hot at all. And then we're going to get this set up to come over here. Yep. So, yep, in the sink. So while Wyatt's doing that, let's do a little calculate our difference there. So we were at 23.3 minus 21.6. So that gumdrop had a difference of 1.7 degrees. So 1.7 degrees Celsius is how much the gumdrop raised the temperature of that water. So not a big change. So think about what you wrote up here. Do you think the candle's going to change it more than that, or less than that, or about the same? Okay. So Wyatt's got us some water. There we go. It's a little bit more than I had, I believe. Which means it's going to take longer to. We'll pour a little bit out. We wanted to have the same amount of water so that it's got the same amount of water to heat. We don't want one to have more and one to have less. Okay.
Good or too much?
No, that's good. All right, so there's our water. Let's see what temperature it is. It came right out of the same sink, so it should be about the same temperature as that other one.
What's temperature?
So if we go with that, it is 20.6 right now. So 20.6 degrees Celsius. Make a prediction. How much do you think it's going to raise the temperature? And we're going to still let this burn 1 minute, 45 seconds. And we'll get our after temperature and calculate the difference. All right. So is that candle in the center?
Yeah.
Pretty good.
And the timer. You need to get the timer.
Oh yeah. Start the timer. Press start. I've got it ready to go. And our timer is gone.
It's ticking.
So one difference that I'm already thinking about is that the gumdrop would go out and we'd have to relight it. The candle's going to keep burning. Yeah, it's going to keep burning. So that might have some
It's already at 21.
difference. And why it says it's already getting higher.
21.4. 29.7. It's gonna get more. I bet it's gonna go.
Why it says it's
24.
going to get higher, it's going to get higher than that gumdrop.
I bet 24.
All right, he's thinking 24.
So,
We got 1 more minute to go.
22. 22.4. I think, yeah. 24. My prediction. 22.8. Yeah, it's gonna get higher than my prediction. 4 months. That's 23.3. You need to climb. Oh, it's touching the bottom.
The flame is, but the candle's
I want to get under. Come on. There's 4 degrees, 5 degrees, 4 degrees. 9, 8, 7, 6, 5, 4, 3, 2, 4 seconds.
not. All right.
Hold
So
on.
we're done. So we're at
Hold on.
23.7.
It burned for extra couple seconds.
That's okay. 23.7. So let's write that
You
down.
can't blow it out. It's the candle.
All right. So 23.7
23.7.
was the final degrees.
Very, very close.
And then let's calculate the difference. So let's stop this timer. Let's go to my calculator. And if we do 23.7 minus 20.6, we get 3.1.
How much the difference?
Okay? So the candle caused a difference of 3 degrees, a little bit more, 3.1. So it raised 3.1 degrees. The gumdrop only raised it 1.7 degrees. So which of these gave more heat transfer to the water?
Candle.
The candle did, absolutely. So different substances do have different heat transfers that they can do. You're going to try to write up a little bit of a conclusion, reasoning, and evidence to explain that experiment and explain what happened. And I'm going to leave that piece up to you. Kind of an interesting thing. All right, thanks for watching. There's the mouse at right.